Good morning, Algebra. I'm going to just go through today's lesson. So if you had any questions, anything you got stuck on, you can refer to this video. To find today's assignment, once you log into Teams, you're going to find your class, which is Algebra 1. And under assignments, you're going to see 1.14 Outliers. And when you find it, just click on the Outliers Excel sheet, and it'll bring you to this page. You want to be on the first page. There's 14.1, 14.2, 14.3, cool down, and a little warm up. We're going to start off with the warm up. A college is looking at the data for its most recent college graduates based on their major. The mean salary for 100 recent college graduates who majored in engineering was $63,000 and $63,750 with a standard deviation of 10 grand about. The mean salary for 100 college graduates who graduated who majored in business was $52,200 with a standard deviation of $19,400, and the mean salary of 100 recent college graduates who majored in the social sciences was $45,230 with a standard deviation of $6,750. Match each histogram to the major based on its description. So just pretend you didn't see that. The graph on the bottom right here is the most spread out of the graphs. So this has the most variation. Among the three majors, the one with the highest standard deviation is going to have the highest variability, is going to have the highest spread. Between the 10,000, 19,000, 6,000, business majors have the greatest spread. This $19,400 is going to be business. And the average here looks like it's around 50 to 55,000, which is what this is agreeing with. It says that their business majors did have $52,000 in that for a mean. So that checks out. The next thing I'm looking at is, well, between engineering and social sciences, the engineering average is significantly more than the social sciences at 63,000 versus 45,000. So this graph in the middle seems to have a higher average. So I'm going to say this has got to be engineering. And the last one has the smallest average and it has the least spread. All those data points are really close together. So that small standard deviation of 6,750 for social sciences checks out. This is got to be the social sciences. And that's it for the cool down. So move on to the next tab. This histogram represents the average amount of money in thousands of dollars spent on each person in the country per capita for healthcare in 34 countries. We also have a histogram and a box plot. One of the values in the set is what's called an outlier, and which one of the values is it approximately? So the outlier is the one that kind of like one value that like doesn't seem to match the data. It's kind of like out on its own. It doesn't seem like it should be here. The one data point that's kind of separated from the all the other ones are right here around 9 and 10. The approximate value of the outlier is, I'm saying it's approximately 10, somewhere between 9 and 10. Let's say it's approximately 10. Number 2 tells us one rule for deciding if a value is an outlier is if it's more than 1.5 times the IQR greater than Q3. Determine whether or not the value meets the definition of an outlier. So we need to find out what Q3 is, we need to find out what the IQR is, and we need to find out if this value 10 is bigger than 1.5 times the IQR more than Q3. So let's just calculate one of these at a time and see if we can get there. So Q3, looking at this graph, is where that rectangle ends. So it looks like that rectangle ends at the value 5. So I'm going to approximate that as 5. The IQR is the width of the rectangle. It goes from 2 to 5. So that Q1 starts at 2, Q3 is at 5. The difference is 3. So the IQR is 3. And 1.5 times the IQR. So if I do 1.5 times the IQR, which is 3. Ooh, I got to write the equals first, don't I? Equals 1.5 times the IQR, which is this number right here. That's 4.5. And the question is, if you looked at question 2, 1.5 times the IQR greater than Q3. So I'm going to take Q3 and add this 1.5 QR. So I'm going to add the 5 and the 4.5. So I need to take this number and add it to this number. Ooh. this number, and add it to this number, and it's 9.5. So what this is saying is anything that's more than 9.5 in the data set is an outlier. And if we approximate the value of the outlier to be 10, 10 is past 9.5, so it is an outlier. Yes, so the value meets the definition since 10 is greater than the upper boundary of 9.5. So this is like the upper boundary. Anything that's over 9.5 is going to be an outlier. That's our upper bound. Anything above that, if there's a 10, 11, or 12, any of that would have been an outlier. Okay, so moving on to 14.2. Okay, here we are. Here we're given that same histogram. We're given all of the data on that histogram. So everything was between 1 and 10. That outlier we said was about ended up being about 9.89. We said it was about 10, so 9.89 checks out. It's pretty close. Number one, just calculate the mean, standard deviation, min, Q1, median, Q3, etc. So let's just use our formulas. For the mean, we just type equals average. And we're just going to take all these numbers just up to there. Oh, what happened here? I forgot the parentheses. There we go. So equals average, don't forget the parentheses. We're going to highlight all those numbers, come back up here, close parentheses. So the average value is about $725,000 per capita. The standard deviation, ST, DEV, we're going to do the one that says .p. I'm just going to double click it. Let's find the standard deviation. And remember, the computer is going to calculate the standard deviation for us. So the spread here is about 1.827. That's about how varied the data is. To find the min is going to be this 1.0813. And you could also just type equals min. And if I wanted to find the min of a data set, suppose the numbers weren't in order or we didn't order it, that min function would work. So, right, that 1.083. Q1, I'm going to type equals quartile.exe. Now, don't forget that after you highlight the data, the computer needs to know which quartile you want. So now that I highlighted the data, I got to tell it that it's quartile 1, so comma 1. Median equals median. I'm just going to spell that one out. Find the median value for this data set, no problem. Oops. Let's get all of it. Okay, there's the median. And Q3, so again, equals quartile.exe. We're going to highlight the numbers. And for the quartile 3, we got to tell it that it's the third quartile, so it's going to be comma 3. And then the max, I'm just going to use the formula again, but again, we know the max is going to be that number at the bottom. It was like 9.8. Yeah, 923. So that one you could easily type it in as well, or just use the computer to find it for you. So we have our, we did number one, we calculated those values. The maximum value of this data set represents the spending for the U.S. So that 9.89, that country was the United States spending on healthcare. Should this be considered an outlier, show your calculations. So we just need to find out what the IQR is, multiply it by 1.5, add that number to Q3, and if the 9.89 is greater than that number, then that's certainly going to be an outlier. So the IQR we find that by just taking Q3 and subtracting that from Q1. We want to multiply that by 1.5, so 1.5 times the IQR. Ooh, I keep forgetting the equals. Anytime you do a calculation, don't forget to type equals first. Okay, so we multiply 1.5 times the IQR is at 4.19055. And then I want to take Q3, which is right here, and add 1.5 times the IQR, which is this number right here. And the upper bound is 9.12165. So anything over 9.12165 is going to be an outlier. And that max value is 9.89. This number is going to be bigger than our upper bound. So anything over this number, which our max is going to be considered an outlier. So the answer is yes. The U.S. value of 9.8923 is greater than the upper bound of 9.12165. Okay, so there we go. Let's look at the next one, number 3. We're going to create a box plot for the data and make sure to label the values on the right of the box plot. What information do we get? So to make a box plot, just highlight the data, no issue there. And then we're going to go to Insert, Other Charts, Statistical, and the box plot is this one right here. Let me just move it over. I'd like to change the title. The title is we'll call it per capita spending on healthcare. Thousands of dollars. Good to label graphs. I know that was one of the questions. Oh, did it not even update? All right. Well, unfortunately, I was not able to do that, but we'll figure that out later. Right now, one thing I want to say is what information do we get from the box plot? So we already knew we got the 5-number summary. We got the min, Q3, the median, Q1, the median, Q3, and the max. But they took out that outlier. So what this tells us is it gives us the 5-number summary like normal, but it also calculates the outlier. And it's going to give us the outlier, and it takes the outlier out of the max. So instead of making 9.89 the biggest, where the whisker goes, it puts that as a point as an outlier and has the whisker stop at the next highest value, which is 6.6475. So the box plot gives us the information of the 5-number summary, like always, but also it's going to give us the outliers. Number 4, although outliers should not be removed without considering their cause, it's important to see how influential outliers can be for various statistics. Copy the data from column A, paste it in column J, and we're going to remove the US from the data set and then recalculate it. So if I take out the US, which is an outlier, how does that affect the data? So I'm going to copy all these numbers. I'm going to highlight all of them except I don't want that last one, not the outlier. I'm going to copy it, put it in column J, which is what the directions asked me to do. So here's J. I'm going to put it up here. All right, so there's all my data, but we took out the US. Let me zoom out a little bit. Did I get it all? A little more. There we go. All right, and now same thing. We're going to calculate the mean standard deviation, Q1, all that stuff again. So the average for mean, the average of all these numbers, the standard deviation. And the idea of what we're really looking for here is if you take out the outlier, how much does that change our summary of the data? The more you start typing these things in, the quicker you get at it. I'm doing this for a while. We're getting a little bit better. Don't forget the comma 1 for Q1. Okay. Median, quartile 3. Remember, we use the .exe one. And that's comma 3 for the Q3. Max. Largest number in this is that one on the bottom. And the IQR, we take Q3 and subtract that from Q1. Okay, So simple enough. Now, how do the mean, standard deviation, median, IQR compare to the original set of data? So when we take out that outlier that was so high, I would expect the mean to go down. And the mean right here is 3.5. The mean above here was a little bit more than that. So when we had that high data, and it was $3.7 thousand per capita. The standard deviation or the spread was about 1.8. Once we take out that high value, I expect the standard deviation to go down a little bit, and it actually went down a significant amount. It went by about 0.3. The median probably isn't going to change that much because it's just one data value amongst 34 of them. The 3.39 versus the 3.49, that's only about 0.1 versus the 0.3 that the mean went up. The mean did change, but not as much. And the IQR was 2.67. That's probably not going to change too much. 2.793. So everything seemed to go down. I would say the mean and the standard deviation went down more than the median and IQR. Okay, moving on to 14.3. Here we have the number of property crimes for 50 California colleges. So one college had 15 property crimes like theft, something like that. One college may have had 51 crimes. Some colleges had 99 crimes. So these are 50 different colleges in California and how many property crimes they recorded. So let's find the following statistics. So we want the mean, which is the average. So the average amount of property theft in all 50 of these colleges, it's a lot of colleges, is reconnecting to server as soon as okay. So we're losing a little internet connection. That's fine. When it comes back, it comes back. So that formula will give us that. If I want the standard deviation, that's STDEV.P. And the reason why I'm zooming out is just so this part is a little bit easier to do. Okay. There we go. It came back. So the average amount of thefts is 191. The standard deviation is 183. The minimum is, I'm just going to write equals this cell right here. That's the smallest. For Q, the quartile, Q1. Ooh, that's not what I wanted. Again, highlight all those numbers. All right, the 768 is on the bottom, so I don't have to keep doing that. Comma 1 for Q1. The median amount of crimes is 107.5. Q3. The max is the 768. I typed equals first, that's how I got it to work. And the IQR is just Q3, and subtract that from Q1, and we're good. Cool. So let's zoom back in so we can look at these numbers again. So are there any outliers? Calculate on Excel and then confirm with the box plot. So to find out if there's any errors, what do we have to do? We have to find the IQR, which we did, multiply it by 1.5, and then add it to find the upper and lower boundary. Sure. So the IQR times 1.5, so 1.5 times the IQR. The IQR is this number right here. Okay. So I need to take the IQR, and I got to do two things with it. To find the upper bound, I'm going to take the 1.5 times the IQR and add it to Q3. So I'm going to do that right here. So I'm going to take Q3, which is this number right here, and add it to the IQR. and that's going to give me 589. That's the upper bound. This means that anything that's over 589.875 thefts is going to be considered an outlier of the data. The lower bound, so if you anything anything that's 322 more than Q3 is an outlier, and anything that's 322 less than Q1 is going to also be an outlier. So an outlier in kind of like the small sense, like it's way too small. So the lower bound is going to be this number right here minus Q1. Oops. Q1 is this number right here, and subtract that from this guy right here, and we get that number. So I'm just going to type what we did here. We took Q1 and we subtracted it from 1.5 times the IQR. So that gives us our lower boundary, and our upper boundary was Q3 plus 1.5 times the IQR. So anything lower than negative 271, well, there's no negative, you can't have negative thefts, so that doesn't matter in this case. But the upper bound is 589. Do we have any schools with over 589 thefts? Looking down here, yeah, 589 we said. There's 3 outliers in this case. 593, 699, and 768. So 593 is an outlier, 699, and 768 are outliers. Right? All of them are past this upper bound. Anything bigger than that number is an outlier, and there's three of those values. Now, if there are any outliers, why do you think they might exist? Should they be included in the data analysis? So should we count those? And do you think there's something wrong here, or do you think there's a reason why we're getting numbers like this? And in statistics, you kind of want to look at that. Why are these numbers occurring? And my thought is there could just be colleges that are a lot bigger or located in an area that has more crime, and so colleges in bigger areas with more crime is going to have more thefts or more property crimes. So as long as we're taking into account all the schools in the area, then I think we should keep these data points in, because it is possible to be in a high crime area with a lot of people, with a high population. So these colleges that are outliers may be much larger than others. Or located in areas that have more crime. So they should be included. The analysis is of all colleges. Not including if it's only an analysis of small schools. So this last part right here, it should not be included. What do you say? Analysis is of all colleges, but not included if it's only, yeah, right. So if these are only small schools, then these outliers really shouldn't be considered, because something's not right in the data collection. Someone may have made a mistake. But if we're including all schools, then these numbers are reasonable. Anyways, okay. Moving on to the cool down. We have a group of 20 students, and they're asked to report the number of pets they keep in their house, and the results are in. A couple people have 0 pets, a couple people have 1 pet, some have 2, some have 3, some have 4, and one person has 21 pets. We have an average, standard deviation, Q1, median, Q3. Would any of these values be considered an outlier? Explain your reasoning. Well, that 21 just screams to me that it's an outlier. Let me just see what the upper bound is. We know Q3 and Q1, so we can find the IQR no problem. And we can find out if that's an upper bound. The IQR is going to be, so this is the IQR. To get the IQR, I'm going to take Q3, which is 2.5 pets, minus Q1, which is 0.5 pets. And so the IQR is 2. If I take the 1.5 and multiply it by the IQR, I can do that in my head. That's going to be 3, but we'll do it here. 1.5 times 2 is 3. And then I need to find the upper bound. To find the upper bound, I need to just add those two numbers together. 2 and 3 is 5. Right? Let's see, wait, hold on. Q3 was 2.5, so I need to take 2.5. That's what I need to add to the 1.5 times the IQR. Okay, so anything that's greater than 5.5 pets is an outlier. 21 pets is way above that upper bound. So yeah, that's definitely an outlier. Yes, 21 is an outlier. It is way above the upper bound of 5.5 pets. Number 2, after being told that they should not count any fish in that report, the value of 3 becomes 2, and the value of 21 becomes 1. Would these change the effect of the median, mean, standard deviation, or interquartile range? If so, would each measure decrease or increase? So if this 21, which became a 1, so we have another 1, and we don't have that outlier anymore, the 3 becomes a 2 because they can't count fish. Well, that extreme value of 21 goes down. So if you take that big number of 21, the average is going to go way down. If I took the average of all these pets, that 21 drove it up. Now, if that 21 becomes a 1, the mean is going to decrease. Also, the spread. That 21 spreads out the numbers more. When you have that 21 turn into a 1, everything's between 0 and 4. The spread's a lot less. So the mean and standard deviation would be affected. They would decrease. Okay. The median and the interquartile range won't change that much because the interquartile range is just the middle values. It doesn't matter what's on the end. We're just going to, when you find the median, you just kind of lop off the ends anyways and work your way into the middle. Anyways, that's it for this lesson. Your homework on Teams is going to be the 1.14 homework. So you can access, turn it in through Teams, and it's also on OneNote under the homework section. 1.1, Unit 1, Lesson 14, cumulative practice. So that's it for today. And if you guys had any other issues, just email me and let me know. Have a nice day. Have a good weekend. Take care. Bye.